Hello, I'm Rick Schultz from High Fidelity Cables, and welcome back to AudioFile. One of the things I wanted to do today, I've had a few questions about what kind of gear do I have sitting on my desk. So I've got a headphone system sitting on my desk. In the end, it's all powering a set of Audi's LCD4. I've got a prototype amplifier from High Fidelity Cables. It's a headphone amplifier that can also drive loudspeakers. It puts out about 27 watts. We've driven some pretty inefficient loudspeakers with it already, not to really huge volume levels, of course, with only 27 watts, but it's a very high current amplifier, so it'll actually drive speakers a little bit more efficiently than a lot of amplifiers in this category. And that's basically because it's, high current output. We've got some recording equipment that's sitting on my desk that you'll see as you go through these videos. On the last few recordings that we've done on AudioFile, you've seen stock power cables to my Shanling CDT 100 Mark II. And we're going to get into that just a little bit because there's been lots of questions about what this thing is, and so we'll touch on that. Over in the front of my desk, you can see the High Fidelity Cables Trinity plugged in with USB. Yes, we're testing for USB for the Trinity. So far, it sounds really great. It should be sometime next year before we actually get that into market, but we believe it'll be a great performer and something that most people want. The Trinity will also be coming now with the headphone jack, which is the typical setup for the Trinity. So basically what happens is you put a headphone jack in out of your preamp and onto your headphones. So it goes in line between your headphones and your preamplifier. And that unit has a 1/4 inch tip ring sleeve, TRS. The tip ring sleeve goes in on either side of the amplifier, the input side, to the headphones, into the little Trinity unit, well, they're not so little, and then out again with TRS to 1/4 inch to your headphones themselves. And that unit makes quite a difference. We've sold quite a lot of those. In fact, that's in part how I ended up with the Audi's. We had quite a bit of support from that company. And this amplifier just runs the Audi's extremely well. They're fairly hard speaker to really get going. They take quite a bit of current in order to drive those panels, and this unit here has just no problem whatsoever. Actually, with any headphone, it'll drive literally anything. So next we'll get to the CD player. So this used to be a stock CDT 100 Mark II, which is a very good player. If for $2,500, this thing really sings. It's a very good overall player. And one of the reasons why we picked it is because it's relatively easy to modify. There's a lot of through-hole components in it that make it easier to be able to upgrade the parts on the inside. If there's a lot of surface mount components, it becomes really difficult to be able to do upgrades on it. And we wanted to do a lot of upgrades on this unit, and we did. So there's somewhere around $5,000 worth of extra parts that were put into the circuit itself. And then we've got an ultimate power cable, basically, wired into the secondary of the transformer. So one of the transformers is gone, and the reason for that is the tubes here no longer are functioning. So we took those out. We took out the tube output stage, and we replaced it with a high current solid state output with really good power regulation to it. We put power regulators, really high quality power regulators throughout the unit. Now, what difference does that sort of stuff make? Typically they're using a power regulator that's going to be a couple of dollars. And the unit sells for $2,500 at retail. So you can imagine that they've got to try to jam all of these tubes build the chassis, make the display, set up the way that the CD is actually held on the inside. All that sort of stuff has to be done, building transformers, and then the circuit boards themselves. So the really expensive parts aren't in the budget for something like this. Yet it still sounds really good because the circuit is really good. When we upgrade to like a $60 voltage regulator, we get a much more accuracy on the input voltage to all of the circuits. And that really cleans the noise that the circuit would actually get otherwise. And so power regulators are really great for being able to clean noise off of the circuit, especially really good power regulators like we've got in this one. We also replaced the clock, and the clock is now about somewhere around $500 to $700. I can't remember exactly what we invested in the clock, but the stock clock would have been, again, $10, $20, something like that. So that's a really huge upgrade in the clocking mechanism of the CD player. It's about as good as you can get in an aftermarket clock. So when you buy a clock, there's always some sort of internal component that actually does the clocking. Just like when you buy a DAC, there's always a DAC chip that actually breaks the ones and zeros and turns that into an analog signal. And this unit here already had a really good DAC chip in it. So we didn't replace the DAC chip, but we did replace the clock. And throughout it, we went through with upgraded electrolytic capacitors. And we also put in a bunch of Vishay 2575. They're called the Naked Vishay. And they're really good resistors. And I know that if you ever put those in some of your gear, you're going to hear some really nice clarity out of that unit because they're just really good. Most of the capacitors that we put in would be Nichicon, and Nichicon makes some really good capacitors that compare with some of the old Blackgates that were out there. This unit probably has a few Blackgates in it as well. Blackgates are discontinued. I've heard somebody's trying to make them again, and I hope that that's true because the Blackgate was simply the best electrolytic capacitor that you could get, and they really perform well. I've got the unit sitting on Audio Points, which is a specialty footer for vibration, dealing with vibration. So the transformers, for example, are going to vibrate quite a lot, and that vibration ends up going into the signal path and amplified and played as distortion. And so you want to try to move those mechanical vibrations out so those microphonics don't end up in the circuit. And the best way that I've ever found to do that is through Audio Points. And I did another video on Audio Points itself. But anything that you have, this one's got the SP1 stand underneath it. And I think that's a discontinued model right now. But really made a huge difference on the amplifier too, because of the transformer and other parts that are vibrating and making noise. Why does that happen? Well, one of the things is because of something called a B field. So a B field is a spinning magnetic field that goes around a conductor and basically is moving back and forth at 60 cycles per second in the power supply. And because of that, wires tend to want to vibrate. And transformers, probably the most of all things, really want to vibrate. And but there's even vibrations, minute vibrations, inside the circuit boards. And these little Audio Points are really efficient at being able to take out those micro vibrations and give you cleaner, clearer, more dynamic sounding music. Now, they're much different than putting something rubberized or something underneath. That basically stops vibration from coming in, but it doesn't help the vibration to get out. So most people think that the problem with vibration is that the vibration is coming from the outside. You're trying to get into your component as you're playing music and that sort of stuff. The sound is coming back and hitting the chassis and causing some sort of problem. But that's not really the problem. The problem is the noise inside the chassis itself, and you want to get that out of the chassis as quickly as possible. And Audio Points are designed to be able to do that. They've got kind of a one-way channel mechanism that allows vibration to flow out, but it can't flow back in. And so they're the best product by far that I've ever heard for canceling noise based on mechanical vibration. And something that I'd highly recommend to anybody that's looking for cups, cones, or footers. Even if you've got a different brand, try some of these. And so some of those are very expensive, I know, but still try these, even though they're not horribly expensive, because they work really well. I've got an ADIS rainbow cart sitting on my desk, and I had this on my player for a period of time, probably close to a month or a month and a half, and absolutely love this cart. I had several carts in the $6,000-7,000 price range, and at $2,700 this basically blew them all away. It's just an amazing sounding cartridge. It's ADIS Rainbow. If you want to look that up. If you're in the market for a cartridge, even if you've got a bigger budget, I'd still go to ADIS and take a look at what they're offering. I'm using a Mammoth Gold right now, which is retail about $8,000, and it's just off the hook. I mean, it's really great. I mean, that's an expensive cart, but a lot of the people that we market to are using carts that are $10,000 or even $15,000 nowadays. So as far as the clients that we normally deal with, that's a very inexpensive cartridge. Now, it might be expensive to some, but we deal with a fairly affluent, high-end clientele. Playing music in the background, which may be a little bit too loud for this video, I'm not sure, but playing the music in the background, I've got Zach Winters, and album cover title is To Have You Around. Now, all Zach's music is fantastic. It's very melodic, it's very well recorded. All of the LPs, if you can get a hold of them, are just really well pressed. Zach Winters is one of my favorite overall artists, and just really great music to chill out to. Nice stuff. You can see here Wynton Marsalis, and Wynton Marsalis. This one is the Magic Hour. It's set up in the player right now, and it's some of the best jazz music you're ever going to find. I like something with female vocals and horns, and the opening track on this one is just wild. You're going to love it. So I highly recommend, if you don't have it already, get Wynton Marsalis, the Magic Hour. You simply won't regret it. Another one of my favorite CDs lately is London Grammar. It's kind of more pop music, but it's got some excellent vocals in it. It's well recorded overall. We use it at audio shows to demonstrate our products with. In fact, we use all of these in order to be able to demonstrate products with. And it's just well recorded, really well recorded, and it's just kind of different. Vocals are really big on it, sound fantastic. Channel separation is really good. There's lots of 3D type of effect within that. Not as much as some discs. I'll cover some that have some really great 3D effects in the future. Always have my Essence of Music sitting on my desk, because I'm always getting in a little bit of new CDs, and I'll take my CDs and I'll treat them with the Essence of Music and the pens that you've seen in the other video, and then I'll import them into my computer on my hard drive. And often I sometimes play the CD. My CD player is just as good as my DAC unit off my computer, and maybe even a bit better. It's just been a bit of a chase. All of my rigs right now, whether it be my analog rig, my CD transport, or my computer import, sounding just fantastic. So I don't care which one I listen to, but I do spend a lot of time with vinyl, just because it's fun. Vinyl is fun, and vinyl is kind of easy to tune as well. So if you're looking for a particular sound, you can adjust that easily with something as little as adjusting the VTA on it. Makes a huge difference. So that's basically it. Now, one more thing I wanted to mention about this CD player and about the amp is they run something unique. There's two different types of fully balanced outputs, and they're both fully balanced, But one of them is unique in the fact that when the output goes out, it's actually taking two single-ended signals. So a full single-ended signal on one side, and then an inverted version of that single-ended signal on the other. And it puts it out to the amplifier so that your cables would potentially have less amount of noise come in them. Now, high-end audio cables don't particularly have a lot of noise in them anyways. They're well shielded, well designed, and for the relatively short runs that we run, single-ended is actually fine. And some people would swear that they're superior. And there's guys out there still building equipment that only have single-ended inputs. And the reason for that is maybe the circuit itself runs fully single-ended. Now on these, the circuit is run fully balanced. And the difference about the fully balanced that we're doing is that on the output pin, you'd only find DC negative or DC positive, depending on what pin you put it to. So it would be, the positive would be DC positive in voltage, and then it would be DC negative in voltage on the negative rail. And they come together to make a single-ended signal, because you have to have a single-ended signal in order to drive your speaker. So the result of all of this stuff that we're doing, even in balanced, is to eventually bring it back to single-ended, because single-ended is the only thing that a speaker can respond to. Okay, so basically what this does is it's got a portion of music on the positive side and then a portion of music on the negative side, and they come together to form a sine wave. And that's unique in high-end audio. Most of them don't do that. They run the single-ended, two single-ended signals together. This one here has a fully balanced input capability. So it will actually take that DC negative on either side, and it amplifies both of them in different channels. And it amplifies the DC negative in one circuit, and it amplifies the DC positive in another completely different circuit. And then it outputs in the balanced mode. Now, what do I mean by that? Didn't I just say that you can't have a balanced signal to a speaker? As long as you understand that the balanced signal comes together as a single-ended signal. So you've got your positive voltage range and your negative voltage range, but they're fitting together. So on one side, there's an electronic pull or push that's happening to the speaker. And then when you put the negative in, there's also a pull or push that happens. Now single-ended isn't really different than that. Single-ended basically works, pull and push too. But this is just different in the way that it delivers that signal to your actual loudspeakers. So on some systems, you can put your negative speaker cable into your wall outlet instead of your amplifier, and it'll still work. So it's outputting a single-ended signal. All of the energy is coming on the positive leg, and it's the negative is only working as a ground. Okay, so it's just changing potential. And that is common to most all amplifiers in the way that they work, where you can put the negative into the ground socket of your electrical outlet, and it'll work the same way as it does going to your amp. Most amplifiers, I would have to say, work that way. This one wouldn't. It needs that negative signal in order to be able to actually deliver it to the speaker. Otherwise, the speaker doesn't see the pull or maybe doesn't see the push. So that's another thing that's quite unique about this. And of course, it works that way on headphones as well. So it's getting a different type of signal that maybe works a little more efficiently than single-ended. It's hard to say that though. Single-ended circuits, if they're done right, are just absolutely fantastic. And balanced circuits can be absolutely fantastic too. It depends on who makes them. So anyways, that's probably enough for one episode. I'm Rick Schultz, and I really enjoy you watching the audio file. Give us a thumbs up if you like us, and we'll see you again soon in another episode.